It's like minus, comma, no, -1, comma, plus or minus 3. Let's see white color. See if that's. Let's see how that goes. Can you guys see it? Yeah. All right. Lagrange multipliers. This is the constrained optimization. All right. So in this case, this is what we'll be looking at. Can you guys see that? All right. Maximize z, which is f of xy, or x, y, z. As before, but now we have a constraint. On which x, y we can use. So let's look at some kind of problem. Was it this one? Someone works at the Apple store? Who's that? Okay, so let's look at the Apple scenario. Okay. Can you guys see that? Gray? No? Sure. I think green is better. Are you guys doing anything for Halloween? What are you doing, Julio? What are you doing? That's not doing anything. You kids are not social either, so you're lucky if you say you have one friend. So your one friend probably is your brother or sister. A dog. Oh yeah, that's very pathetic, man. It's just like everybody has animal. That's how you know you're so lonely. Why do you need to have animal? I'm like, and it's just, sorry. Anybody who owns, like, I find it, why? What? Yeah, again, yeah, that makes it even like because you're not social, like you don't know how to socialize with others, so that's why you get something that you don't have to compromise yourself just to have that feeling. On top of that, you have like how do you sleep with the animals? Like, can you go one day without showering yourself? So now you're hanging out with somebody who hardly gets showered maybe once a week. That is if you're lucky. Do you see that? No? Am I the minority in here? Yes. Yes, Kenna. Yeah, but you gotta shower them. Like my skin is soft too. I gotta lotion them. I gotta go through this hygienic process. But that dog is like on your bed. If they stay outside, like kind of like wolf, where it protects you or you're hunting, that makes sense. But like those tiny, what is the chihuahuas? Like, why? The cats, why? Like you don't even eat them. So what's the purpose? Like, see, roosters, chickens, that makes sense because you raise them, you feel good, you're hungry, then you kill it, you eat it. So, like even goats too. Have you ever seen goats that come to you, you could pet them, they're looking for petting and all that? They're cute too, but that's edible, so you can do that. So, yeah.
But we are social.
What?
Social distancing.
Have you been waiting for that the whole time? The joke, like I'm gonna wait for that.
You said the dog isn't edible though.
Well, I mean, I've tried to find the market to eat the dog, but in America it's illegal to eat dog. Like you cannot, it's illegal. But um, it's just. Have you ever seen the butchering of dogs in videos? It's so sad, man. Even to the last moment, they're still like holding on to their masters, even though the master is like slitting their throat, cutting it, and everything. It's just sad, man. Yeah. Be vegan. Has anyone ate dog meat before? I tried to find one in China. I couldn't find it. It's so, like they wouldn't tell me unless I look Chinese. So Apple makes. How many of you have pets at home? Raise your hand. Wow, I've insulted all those people. Apple makes X iPad. I'm sorry, guys. It's just think about it. You guys can't even go on vacation. Well, like, let's say you want to travel for 2-3 months. What are you gonna do? Exactly. Yes, Kenna. What? Oh, your neighbors taking care of your dogs for 2-3 months? What? No neighbors will do that unless like you're super nice and Mormons. Mormons are the nicest people. They're the nicest people. Like, I wish my neighbors are Mormons. They're like, you give them anything, they'll take care of everything. But nobody will take care of someone else's dog for 2-3 months.
I don't know, my friends who, like, we went to their house for D&D, like, they had, like, their friend's dog for, like, such a long time. Like, I thought it was legitimately theirs, and then one day they were, like, all gone. They're like, oh, yeah, my friend picked them up finally. And I'm like, they weren't your dog?
All right. X iPads and Y mini iPhones. Generating revenue of now at the Apple market, those financial people, they don't use this simple equation. It's a little bit more complicated, but you get the gist of it. So the market is saturated when all right. So the question becomes, how can we maximize revenue? And I get to use this color now. We want to find X, Y satisfying G of X, Y equal 4. That maximizes That's our goal. Don't you guys like this new color now?
Horrifying.
Why is it horrifying? Do you not enjoy colors in life?
It's like Comic Sans, but
It's like Comic Sans?
it's like Comic Sans if you put it into a color.
What? I'm not understanding him. What's happening over here? Nothing? Okay, all right. I'll accept that. That I understand. All right, so initial guess. without doing anything, we could see why that could happen. 2 maximizes it. X and 0 will give you 4, right? I mean 2 comma 0. Which gives us f of x, y, gives us what? 16. When we take it back to the original functions. The question becomes, can we do better? Can you guys do better or not? And what are you dressing up for Halloween though? Over here? I know Rin showed me, but she lost her costume, or you don't fit into it because you got, like, you're older now.
This year, like, me and a few people are going to get on FaceTime on Discord, and we're gonna dress up for like.
So it's a Zoom meeting.
Kind of, but it's on Discord.
Yeah, it's just a remote meeting. Yeah.
I think that's what we're gonna do. But like, the virus rules the best.
The worst thing about COVID-19 is it's making us less socializable. Like 5 years from now, you guys are gonna hang out even less and less. Like, yeah, let's hang out over the phone or something like that. That's what's gonna happen. Huh?
Not too terrible. Like, I think.
It's not too terrible. You're proving my point.
Oh my mom, it's not the social isolation that makes me sad. It's the fact that you all have to go to school through all of this.
Oh, okay. I enjoyed going to school. Remember in high school, have you ever ditched any day?
No.
I did it one time. I hated it. It was so boring. Like, I just watched the daytime TV shows that had soap operas. By like 12 o'clock, I was so bored. I was like, this is so boring. What's the purpose of this?
Yeah, but like try teaching yourself like this organic chemistry, but by yourself.
Yeah, I mean, that's why you make friends.
How can I make friends in my class if like you can't even see each other?
You make them friends beforehand. You guys don't do that? Like, if you go to get it, okay, here's my thing. Pick a degree that you want to do and find a group of friends that most likely you will share classes and be their best friends, and you will help each other. Get like 3 to 4 people. And that's how you make friends. You buy them coffee one time, and then the person will buy you coffee next time. That's how it works. And you say hi to them when you see them with a smile. It's so funny. I'm teaching you how to make friends. Do they have books, How to Make Friends for Dummies? It's called, what is that? Is it Dummies? Yeah. Do they have it? How to Make Friends for Dummies. What? All right. So let's look at, before we use the Lagrange multiplier, let's look at some definitions. The objective function is what we want to maximize or minimize. Maximize or minimize. Now comes the constraint part. Is g of x constant, which is the fixed one. We'll come back to this Apple problem. Daniel, I'm going to use the color since you were hating that color. It's like Skittles, right? Or the rapper. What's his name? Stupid? No, Tekashi 69. Yeah, that's his. No, I thought that his name is Stupid, but his song is called Stupid. And he misspelled it too. Stoopid. You guys don't know what I'm talking about? Oh, no, I think that song is too rated R. I can't show it to you guys because we have children amongst us. Like you over there. I call you guys kids no matter what. See, when you get to my age, y'all are kids. Yeah, I'm 59. Yes, I am. Yeah. Yeah, I know. 6 more years. So we're going to look at it in the third dimension. What point on the plane is closest to the origin? So if you look at a plane and I want to know what closest to the origin, essentially what are we doing? We're like making it like some kind of like spherical, right? From the origin, I want to know where the closest part is, and it's straight, and we're looking at all the straight lines from the origin. And if you're fixed on origin and you draw the straight line, basically you're looking at a sphere. And in this case, we're looking at top half of the sphere. Objective, minimize so that's the like sphere, or we can make algebra simpler. Instead. So let's look at the constraint in this case. Three x plus 5y plus 7z equal 10. Okay? That's the constraint. That's what's going on, okay? Now let's go back to the apple problem again. I should play that next class. Takashi's. What's his name? It's Takashi 69. What's his name, right? I don't know why he has a Japanese name to it. He's like half white, half Mexican, I think. What? Huh? He's what? No, just say it. Finish it. Weeb? I don't know what weeb means. Kids lingo. All right. So let's go back to the original problem. Let's go back. I know he snitched. That's how he got out of the jail. It was in the news. All right. So let's go back to the apples problem. Apples goal. Maximize the objective function. Subject to the constraint GX. Oh, we're gonna have the exam next Monday. Okay? Yeah, next Monday. Today's Monday. Yeah. Yeah. What Lagrange? What? Why? Yeah, it gets fun. Actually, Lagrange is easier than the other one. Yeah, the unconstrained one. I mean, why do we communicate? That's one of the skill that we need to have as a human being to make friends. That's why we have words. No, I'm enlightening you guys. So you guys learn how to make friends. So by end of the semester, each of you will have at least 2 friends. And also we'll catch COVID-19. All right. So let's look at it. Clever geometric idea. Graph the constraint. In the 2-dimension. Note that this is a level curve of G. Then graph the level curves of the objective function we want the highest value of f we can get. That will occur where the level curves of f are just barely touching the constraint. So they are tangent, hence parallel. So they are tangent, hence parallel. So how do we solve the apple problem? All right, ready? The second CGI. So we're gonna look at that. Do you guys remember this part? Remember that here it comes. Gradient vector, partial point perpendicular to the level curves of f. And then also we're going to look at the point perpendicular to the level curves of G. So once we have that, we could say that, so the level curves of f and g are parallel. Oh, sorry, are parallel when their gradient vectors are parallel. We're going to use a Greek letter now. So f equals lambda g for some scalar. That's the symbol lambda. Man, it's cold. My toes are so cold right now. Are you guys, like, even though I'm wearing shoes? Are you wearing socks and sandals? Who is wearing socks and sandals on a cold day like this? No one's wearing it. Good. Weren't you traveling from, like, what is it, Minnesota? Where? Yeah, isn't that cold? Super cold over there? I was like, what was the temperature over there? Huh? Oh my Lord. Like, I was in Milwaukee, yeah. First week of November, it was so bad. Okay, so let's look at it. What's going to happen over here? I'm just giving you the English explanation of what we're doing over here. This technique is called Lagrange multipliers. Hence the lambda. To find xy and the lambda. These are the things that we need to find. So let's go back to the original problem, the apple problem. You kids ready? All right. For the apple, the gradient vector, it gives us what? 8 and 6, right? And gradient g is what, guys? 2y. So we saw okay. What should I have for dinner tonight? What is it? I had Italian food for lunch, so that was good. Any hint yet, kids? William? What kind of food? What? Brisket. Ooh, barbecue. Lucille's. That's the place called. Oh, I mean, thanks. Good call. But I don't have dogs, so the bone, I have to throw it out. So I like the whole idea of dog living outside and like surviving on their own, like kind of wolf, like stray dogs. That's a good idea, right? Yeah? Yeah, so dogs should become like cat. All right, so let's look at it. How could we solve the problem? One of the combination is 2 lambda x, 6, 2 lambda y. And the third one combination is what? X squared plus y squared equal 4. So we're going to use these three equations to solve for that. So this gives us 2 equations and 3 unknowns. And we have this extra equations, this 3. So how do we go about solving this? So let's look at it. White background is pretty cool, right? You get to see all the colors and all that, right? Miss Yamat? How'd you get the name Princess? Do you have brother and sister? Well, what are their names? Did they hate you? Is that, are you the oldest one? Oh, that's why. Yeah, you were the experiment. And it's like, oh. You know, parents could be evil. You know that, right? I don't know about Princess parents, but they can. She goes back. Did you hate me when you named me? All right. No. What is this? Long time ago when I taught this class, this kid's name is this. In one word. Yeah. That's the first name. And I'm not like, and then he had other brothers too, and their name was, what is it? Damn it. Jesus. And I forgot the third one, so yeah. That was the first name. I'm like, wow. You just, yeah, Jesus is the Lord. Jesus is the Savior. I'm like, they were very odd. I think they were homeschooled. They came to, yeah, so.
You like give them a nickname or anything? Like to make it shorter?
Like, what am I gonna like? Jesus, Jesus? I don't know. All right. Can you get the yellow? No. So let's look at it. All right. You already have some idea how to solve for it. Solve the first two equations. For x and y in terms of lambda. I'm going to write lambda like this so you guys don't mistake with my x, okay? The way I write the x's. Then plug them into the constraint and solve for lambda. So when we solve for the first two equations, what do we get? X equals what? 4 over lambda. Y equals what? 3 over lambda. Okay? Now we plug it into the third equations, into the constraint one. We get 4 over lambda square plus 3 over lambda square equal 4. And that, it gets kind of easy, lambda square, and you will end up getting what? 4 lambda square equal what? 16 plus 9, that's 25. So lambda equals what? Plus or minus 5 over 2. What? No, it's just some general, like, but if you look at it in like thousands of equations, right? If you're producing like millions of it, that decimal becomes readable. Do you see it? So, someone had a question back there? Name tag, buddy. So now, what are the options you have? What happens if lambda is 5/2? X is what? 8/5. And y is what, guys? 6/5. They have Lucille's at the Red Rock, right? What time they close? What time they close? I hope they don't close before 9. And if lambda equals -5/2, what is x? So, here's one of the things. You cannot mix match it if you use certain lambda. We can't mix and match positive and negative x's and y's. So we get combination 8 over this. That combinations, and the other one is -8/5, -6/5. And this gives us what? When you plug it in, you get a big number, and which is the maximum. This gives you the minimum. And therefore, we need to know what is f of 8. That gives us much better number, which is 20. Much better than the initial guess, which was what? 2,0. The initial guess. So here's some common mistakes people tend to do. Raise your hand if you're still copying it. Okay. Oh, what just happened? Y'all ready? So a common pitfall. How do you simplify something like 2x? One of the things people tend to do is what? Divide by x, and you get 2 equals lambda y. When you do that, you are throwing away possible solutions coming from x equals 0. So you could never do that. Safer way of doing that problem is 2x equal lambda y x would be 2x minus lambda y x equals 0. So from that, you see x equals 0 or 2 minus lambda y equals 0. Then pursue each possibility. two different solutions. So now the orthogonal gradient theorem. Orthogonal gradient theorem. No, that's it. No, I'm giving a different theorem right now. Yeah. So suppose that is differentiable in a region whose theory. Oh, what is it like? Julio, did you find out that if the apple, like you write it down and it types it up?
It does for words. So like, say that will do it for you.
But not mathematical symbol. That's what I thought. Yeah, that's the new coding is to have. Like for example, we write it like we write it like this: x squared dx, and can it recognize that? That's the one. Where did you try it on? Oh, and so what happens? Like it types up everything but the mathematical equation. Oh, so it tries to translate it and it cannot, and it messes it up instead of leaving it at the image. Okay. Contains a smooth curve. What are you guys gonna do? Like hang out on a thing, dress up? That just defeats the whole purpose of like dressing. I was like,
We're working with what we've got. We're gonna stay COVID-free in this environment.
you kids are gonna catch it, and you're gonna heal yourself in the process. You just don't hang out with old people like me. So like you could hang out with your kids, but if you hang around with me, I'll die because I'm so old. So what? Oh, yeah.
Yeah, some of like the people are like the most so you care about the world here at D&D.
Do you guys dress up when you do D&D?
Not typically, no.
So from that, if P naught is a point on C where F has a local maximum or minimum to its values on C, then the gradient vector is orthogonal to C. Orthogonal to C at P naught. That's very cool. It's just telling us that when you have the point, if it has a local minimum or maximum, then we know that it's orthogonal to that point C, which makes your life so much easier now. Okay, I'll stop right over here.